All right, so here we are going over some notes for the second semester final review. Now, what we're doing here is these are just some things to help you, whether formulas or ways to do a problem or tips or what have you, to get you ready for the second semester final. You'll be taking that here in a couple days, depending on what period you have. And just so you know, this will help you just prepare a little bit more. All right, so we're going to start off, and we kind of take this in chunks based by the review assignment and what each section kind of talks about and things of that sort. So we're going to start off with questions 1 through 12 on the review, which basically deal with the exponent rules. So the first rule we're going to address is, what if I have a to the b times a to the c? Well, what we're basically doing there is what is called multiplying by common bases. Okay, remember, common bases means they're the same base. In this case, the base was a. So what we do there is we add the exponents. So when I come in here to multiply these two expressions, I'm going to start off and I'm going to multiply my coefficients because they are not the base. So I'm going to go 3 times 4, and that gives me 12. Then I look and I have a common base of x. I have x to the second power and I have x to the fifth power. So what I'm going to do is I'm going to take that and I'm going to add those. So it's going to be x to the 2 plus 5. So my final simplified answer would be 12x to the 7th. Okay, for the second one, if I take a power and I raise it to an exponent, okay, so b to the a raised to the c, that would be multiplication. So I take that exponent and I bring it into all of the different terms inside. So for example, here I'm going to take the 4 to the coefficient of 2 and to the power x to the fifth. So what that leaves me with is 2 to the fourth times x to the 5 times 4. Okay? So we start off and we go 2 to the 4th. So 2 times 2 is 4, times 2 is 8, times 2 is 16. X to the 5 times 4 gets me x to the 20th. So that would be our simplified expression. This next one is dealing with, what do we do if we divide common bases? So if we divide common bases, we subtract the exponents. Now, just a little tip here. Remember, we talked through the school year that it's kind of like just simplifying the fraction. So if I have 6 x's in the top and 3 x's in the bottom, those 3 are going to cancel with 3 of the ones on top, and that would get me 3. Or x to the 6th minus 3 gets me x to the 3rd. Now notice the x to the 3rd stayed in the top. And the reason that is because x to the 6th, there was more x's in the numerator of the fraction than in the denominator of the fraction. So now we have y squared on the top and y to the 8th. So that y squared is going to go into that 8 and leave y to the 6th on the bottom. So my simplify in the denominator. So my simplified expression is x to the 3rd over y to the 6th. Okay, let's try the next one. So the next rule we're going to focus in on. Anything raised to the 0 power. So any base raised to the 0 power is 1. Okay, so remember, be careful here what the base is, but any base raised to the 0 power is 1. So if I look here at this problem, 6 to the 0, 6 is definitely the base to this expression. So what I do is I simply go 6 to the 0, and that would equal 1. Now, just be careful, just on a side note, remember that if we do this, if I do negative 6 to the 0, in groupings, that is 1. But if I write it this way, then the base of the exponent is the 6, and that would simplify to a negative 1. So be careful there. Make sure you understand what is the base each time. The next rule that we're just going to go with is the negative exponent rule. And what that simply does is it does not make the coefficient negative or positive. All it simply does is switches the location in the fraction. So if I have a negative exponent on a base in the numerator, it switches that base to the denominator and becomes a positive exponent. So in this first example, what is my base? And the base would be the x. The 12 does not have an exponent on it, so it is literally just going to stay a 12 in the numerator. But x to the negative 2 is going to go to the denominator and become x squared. Okay, over here, I look, my base of my exponent is x to the negative 2. It's in the denominator, so that is going to move it to the numerator. The 3 is going to stay right where it's at because it is not part of a base. So that one would simplify to 3x squared. Now, to finish up this topic, remember when we talk about being simplified, we have a couple rules. Number one, there are no negative exponents, so we do not want negative exponents. Simplify your coefficients. So if I have, 8 over 4, I'm going to simplify that to 2. Or if I have 2 to the third power, I'm going to multiply that out and make it 8. Okay, so simplify your coefficients. The last thing is make sure you have no common bases. So if in your problem you have more than one x, for example, you need to put them together. Either use the multiplication rule, use the division rule, use the power of a power rule, whatever, but those x's have to simplify together. So if we take a look here at this first one, I have 16 x to the fifth y over 6 x to the third y to the eighth. So the first thing I'm going to do is I am going to simplify my coefficient. So 2 goes into 6 3 times, 2 goes into 16 8. So right now I have this as 8/3. Then I look at my x's. I have 3 in the bottom, I have 5 in the top. So those 3 are going to cancel with those 5 and leave x squared in the numerator of the fraction. The second thing, I have 1y in the numerator, I have 8 in the denominator, so that is going to cancel out, and you're going to be left with y to the 7th in the denominator of the fraction. On the second one here, we have 6 to the negative 2, which is a negative exponent. So remember, that is going to take that base and move it to the denominator. So it's going to become 6 squared. So that means I have 1 over 6 squared. 6 squared is 36, so I would have 1 over 36. And that's how we do those exponent rules. Now, understand, this is just a quick review. It is not an all-encompassing lesson on exponents. It is just a quick review of some of the highlights to get you back in the mindset of working with exponents. The second category we're going to look at is how do we handle operations with polynomials. So the first topic we're going to address is how do we find the sum. So remember, sum is addition. So what we do when we find the sum is we simply add like terms. So what I'm going to do is I'm going to start off and I look and I have an x and I have a 5x, so I'm going to add those together. Remember, this is 1x plus 5x, which is going to give me 6x. Then my second part here is I'm going to take and I look for another like term. And here I have a positive 4 and a negative 9. So positive 4 plus a negative 9, and that is actually going to give me negative 5. So positive 4, negative 9 gets me a negative 5. Remember, I cannot put the 6x and the 5 together because one has an x, one doesn't, and they're not like terms. Okay, that's how we add. Find the difference. Remember, difference is subtraction. In order to do subtraction, the easiest way I have found is simply change the subtraction to an addition and then change everything thereafter, right after the sign in the second grouping. So here now I'm going to put my like terms together. I have 4x and I have a negative 2x, which is going to give me a positive 2x. Then I'm going to come back in here. I have a negative 3 and a positive 8, and that's going to get me now a positive 5. So 2x plus 5. And that's how we do subtraction. To distribute, what we simply do is we multiply each term inside the parentheses by the term on the outside. So what I'm going to do is I'm going to take this 3x, and I'm literally going to multiply it through. So 3x times 4x squared, 3 times 4 is 12, x times x squared. Remember, we would add the exponent, so it'd become x to the third. Then I go to the next term, 3x times negative 5x, and that's going to give me negative 15x squared. And then I'm going to take the 3x times the positive 8, and that is going to give me positive 24x. And that's how we would distribute. Now, this last one here is finding the product. In other words, when it's a binomial times a binomial, remember what we're going to do is we do what is called FOILing. It's just the distributive property repeatedly, but it is FOIL. So what we're going to do is we're going to simply take and we're going to say, okay, I'm going to take the first and multiply it to the first. So first times first, x times 2x is 2x squared. Then I'm going to multiply the outside. So x times negative 4 is a negative 4x. Then I'm going to multiply the inside. 5 times 2x is a positive 10x. Then I'm going to multiply the last. And 5 times negative 4 is a negative 20. The next thing I'm going to do is I'm going to look for like terms, which is those right there. They both have 1x with them. So I have 2x squared. Negative 4 plus 10, that's going to give me a positive 6x. And then I have minus 20. And that is how we FOIL. Okay, so that gets you through some of the polynomials. Once again, that is an overview of the topic of operations with polynomials. By no means is it a full lesson on how to do that. If you have more questions, just ask in class. More than happy to help. Okay, this next section that we're going to focus in on is factoring. Okay, so when we look at factoring, there are many different types here that we're going to focus. We're going to do GCF factoring, greatest common factor, trinomial factoring, grouping, difference of perfect squares, and then we're also going to talk about finding zeros and solving by factoring. So the first thing we're going to do is factor by a GCF. To do that, what we're simply trying to do is factor out the largest factor of everything in the expression. Remember, the leading coefficient cannot be negative. Okay, so what we're going to do is we're going to start off and I look at 15 and 20, and the largest number that 15 and 20 have in common is a 5, the largest factor they have in common. Then I look at x squared, and x, the largest variable they have in common is x. So what I'm going to do now is I'm going to take each of these and I'm simply going to divide it by 5x. So 15 divided by 5 is 3. X squared divided by x is 1x. Negative 20 divided by 5 is negative 4. X divided by x is gone. So we have 5x times the quantity 3x minus 4. Now on this next part, when we go in, just a little note, I'm going to show you one just real quick here off to the side. If I gave you something like this, negative 8x, let's say plus 12. So if you notice, you have this negative here with your leading coefficient. So what we would do, 4 is my biggest, so I would take out a negative 4. So I'm going to simply divide both of those by a negative 4, and that would leave me with 2x in the first expression. In the second expression, I would have a 3, a negative 3. So that is how you do that if that leading coefficient is negative. Just make sure you take that out. All right, let's jump back here to a different style of factoring. We have factoring a trinomial. What we simply are going to do is we're going to kind of walk through a couple of them here. So factoring a trinomial, the first thing we always like to look at is we look at this last sign. Now, since that is a minus, that tells me my signs are going to be different. So I look back. This one tells me that the biggest number is going to be a positive. So now off to the side, what I'm looking for is they multiply to give me a negative 14. They add to give me 5. And we said the biggest number is going to be the positive. So that means I would have negative 1 and positive 14. I would have negative 2 and positive 7. And if you look, that one is going to be my combination. So my factoring would be x plus 7 and x minus 2. And that would be the factoring of that trinomial. So just so you can see the difference, let's look at this second one. So on this second one, I look at the last symbol. Since that is a plus, I know my signs are going to be the same. So I look back and I know that both signs are going to be a negative. So now I come over here to the side. They multiply to give me 12. They add to give me a negative 7. and both signs are the same. So I'm going to go -1 and -12. I'm going to go -2 and -6 and -3 and -4. Okay, and I look for which one will give me a -7, and it would be a -3 and a -4. And that is how we do factoring a trinomial. Now, to factor a grouping, what we're simply going to do is we're going to start off and we're going to group them into two binomials. So then what we do is we look at the first one and we say, okay, what can I take out? What is the GCF? And out of that first one, it would be x squared. So we would have the quantity x plus 8 left. Out of the second one, we have a -5. And if I divide those by a -5, I get x plus 8. Now, when you're done with this step, what is left in your groupings should be the same. If it is not, you have made a mistake or it cannot be factored this way. So then what we do is we take the GCFs that we took out, they go together in one grouping, and in your other grouping is that binomial that is left. And that is how we do factor by grouping. Okay, third one, or next method is factor the difference of perfect squares. Now, remember, to be the difference of perfect squares, the first number has to be a perfect square, the last term has to be a perfect square, and it has to be a minus. That's why it's called difference of perfect squares. So what we do here to factor this is we literally start off with our groupings. I take the square root of 25x squared, which would be 5x, and 5x. Then I take the square root of 36, which is 6 and 6. And then I'm going to go 1 plus, 1 minus. And that is how we factor a difference of perfect squares. All right, now how do we find our zeros, whether already in factored form or needing to be put in factored form? Okay, so the first thing what we're going to do is if it's in factored form, what we literally do is we take each of our factors and we set it equal to 0. And then we simply solve it. So here I'd minus my 3, and that's going to give me x equals -3. Here I'm going to add my 4, and that's going to get me x equals 4. So my solution here would be x equals -3 or x equals 4. Over here on this other one, the first thing I got to do is I have to factor it. So I look and I have my x and my x. This sign tells me I have different signs. This looks back. My biggest number is going to be negative. And then I look over here, they multiply to give me -12 and add to give me a -4. So my bigger number is negative, so I have 1 and -12, 2 and -6, 3 and -4, and we should see that it's 2 and -6, so plus 2 minus 6. Now we take those, set them equal to 0, and now we solve those, and that's going to get me x equals -2, or I solve the other one by adding the 6, and that's going to get me x equals 6. And that is how we do our factoring or finding our zeros, our different forms of factoring, and solving a quadratic equation using the factoring method. All right, this next part, I put multiple choice on here because what this is kind of dealing with all the graphs of a quadratic equation. So when you look at this, you're going to be dealing with things like they're going to give you an x-intercept and they want you to find what the equation would be. You're going to get an axis of symmetry and you need to find what the equation would be. A vertex, and you need to find from a graph, you need to be able to find. So what we're going to do is we're going to look at this first one here. If given an x-intercept, what you're going to do is you're going to be working backwards. In other words, you need to ask yourself, what factoring pattern would get me those x-intercepts? Okay, so it's basically the reverse of the last two problems we just worked right there above. So if I look at this, I want a +5. So what that means is my grouping should have been x minus 5, because I take it over across the equal sign when I solve. Since I have a -4, then my grouping would be x plus 4. Now, if we just refoil that, we would get x squared, and then we would have plus 4x minus 5x and minus 20. We'd combine our like terms, and we would get x squared minus x minus 20, which would be b. And that's how you would do that process if given the x-intercepts. Second, if I'm given the axis of symmetry, what you're asking yourself is you are using this formula, x equals negative b over 2a, and that is how we find the axis of symmetry. So what you simply do is look at your b's. Remember, your b's are the ones attached to the x. And you also look at your a's. So the ones in front of your x squared, and you ask yourself, which ones would give me an x equals 3? So if I look at this, I'm going to start and I'm going to say, okay, if I go 3 divided by 2, is that going to give me 3? And the answer is no. So right away, I know A and B are not the answers. So now I'm going to take and I'm going to look at C. And C is a positive 6. So if I go negative of 6 divided by 2 times 1, well, that's going to give me a negative 3. That's not what I want. But let's try D now. So if I go here, it's negative of a negative 6 divided by 2 times 1. Well, negative of a negative turns a positive. 6 divided by 2 is a positive 3. So definitely D is my answer. So that is how you do that process. On the next one, they're going to give you a vertex. Now, there's actually 2 ways to do this process. Number one, you could do it exactly how we did the axis of symmetry. And that is going to give you the x value of the vertex. The second way that you could actually do it is you could plug the vertex in, the negative 4 in for the x, the 2 in for the y, and you could see, does it make the equation true? If it does, then that's the equation for that. So what I'm going to do is I'm going to start off with my axis of symmetry. So I'm going to come in here and I'm going to say, okay, x equals negative, and I want it to be a negative 8. So I'm going to start off and I'm going to say, okay, if I take 12 and divide it by 2, does that give me a negative 4? And the answer is no, not going to work. Okay, what if I take negative 4 divided by 2? Nope, that's not going to work. So I've already narrowed it down to 2 questions. So 2 options. I have A or B. So I'm going to try A first. So if I go negative of my B divided by my 2A. So negative of 8 divided by 2 times 1. So negative 8 divided by 2 is a negative 4. Okay, let's try the other one. If I go negative of negative 8 divided by 2 times 1, negative of a negative turns that positive, and that would get me a positive 4. That's not what I'm looking for because I know the x value has to be negative. So I know my choice has to be A. Okay? Now on the second one, literally if you just plug negative 4 in, here, negative 4 squared, that's a positive 16. And then 8 times negative 4 is a negative 32. Okay, so if I take a positive 16 added to that negative 32, that gets me a negative 16. And that is a typo. Sorry, I apologize. That should be a positive 16 on that problem. I apologize for that. Otherwise, that is, oh, sorry, not 16. Let me try that again. That should be a positive 18 for my C value there. I apologize to make that work. Okay, but that will work either way as well. All right, let's take a look at this next part. Vertex form for graphing. Now, remember vertex form is here. I give you the equation of this. Y equals A times the quantity x minus h squared plus k. So if we look, we have 3 values that are doing things. A, that remember is a stretch if it is a number bigger than 1. It is a shrink if it is less than 1 but greater than 0. Remember, if it's a stretch, we said it makes a tall, skinny U. If it is a shrink, it's going to make more of a bowl-shaped U, a kind of a, it's going to shove it all up, so it's going to be kind of more rounded, that kind of a look for that U. And then A also controls the reflection if A is negative. Okay? H, remember that shifts me left and right, but it shifts the opposite of what is written there. So if it said -5, that's going to go to the right 5. If it said +5, that's going to go to the left 5. So it's the opposite. K is the up or down, and it goes with the sign. So when I look at this graph, I ask myself, okay, what is going on? So if I just estimated kind of what is happening already here, I'm going to start in and I'm going to say, okay, it shifted right 3. And the reason I know that is my vertex is clear over here. I also shifted down 1. It also reflected. And if you notice, if I went right 1, down 1, I'm not hitting that point. So that means there is a stretch there. And the reason it's a stretch and not a shrink is because it is going skinnier, right? It's inside of that, so it's going skinnier of that. So when we look at these things, then we put that all together. So I'm going to shift right 3, so that means it should be a -3. So we know it's not A, and we know it is not D. It's going to shift down 1. So if you look, it can't be B because the up and down go with the sign. So it has to be C, but let's just double check. It has to reflect, and it is negative, and it is a stretch, meaning my number has to be, my A value has to be bigger than 1. So that is how you take a look at those quadratic graphs, and you work with what they're asking you to find. All right, so the next section that we're going to look at is simplifying radicals and radical operations. So this one we didn't do that long ago, so we should be able to kind of go through this pretty quick. Remember here, we're looking for the largest perfect square that is a factor to the radicand. So square root of 32, remember we're going to break that down into square root of 16 times 2. And then you look at that, square root of 16, that's going to come out, and it's going to give me 4 square root of 2. On this other one, here on the second one, I have 5. And then I look at the square root of 18, and the largest perfect square is 9. So now I'm going to take the square root of 9. That makes a 3. Remember, we multiply that to the 5, so that would make 15 out front. In that coefficient spot, square root of 2. Here, when I go to multiply these, remember we go outside to outside, coefficient to coefficient. So 2 times 3, that is 6. And then I go inside to inside. 6 times 5 is 30. 30 does not have any perfect square factors, so that would be my simplified answer. If 30 did, I would break it down further. Okay? Now let's talk about some division here real quick. The first thing I'm going to do is I'm going to separate it. So square root of 3 over square root of 64. Then I look at this and say, okay, what is the square root of 64? And that is 8. That's a perfect square. So my simplified fraction would be square root of 3 over 8. On this last one, I have 5 over the square root of 7. Nothing's a perfect square, so I have to do what is called rationalizing that denominator. So this is where we multiply by that FFU, fancy form of 1. So I would end up with 5 square root of 7 over the square root of 49. And since we did that, now we have 5 square root of 7 over 7, because the square root of 49 is 7. And that's how we do that process of simplifying and some operations. Next part here, we're going to look at how do we solve quadratic and radical equations. So here, remember what we do, the square root method is we are going to isolate the part that is being squared. We take the square root, and then we solve whatever is left. So the first thing I do is I look, the part that is being squared is right there. It is all by itself, so I'm going to take the square root of both sides. Remember that cancels, and that would leave me x plus 5. Now, be careful here. Do not forget that inserts a plus or minus 3. The square root of 9 is 3. You have to put the plus or minus in. Now we're going to subtract 5 from both sides. So what we end up with is x is equal to negative 5 plus 3, which is negative 2. And then we also have the negative of that, which is x equals negative 5 minus 3, which is negative 8. So that's how we do that process. On the second one over here, I'm going to take and I'm going to minus my 15. I'm going to rewrite it since my first problem there kind of morphed into it. So I'm going to take this and I'm going to minus my 15, because what is being squared is this part right here, just that variable. So I'm going to minus my 15. I get x squared is equal to 10. Now I take the square root of that, and that gives me x equals plus or minus the square root of 10. If it asks for it as a decimal, you would literally just take your calculator now, and you know that's going to be just slightly over 3. So if we take 10, take the square root of that, it's going to come out to be 3.2 rounded, we'll say. So plus or minus 3.2. And you have to read the question, make sure you understand, is it asking for the radical or for the decimal? Okay, the other way that we can solve a quadratic equation is by using that quadratic formula. I've listed the formula right here, x equals negative b. Remember, we got that song if you want to sing it. X equals negative b plus or minus the square root, b squared minus 4ac, all over 2a. Okay, so what you do first is you start off and you say, okay, this is a, b is a 1, c is negative 5. So now what we do is take that and simply plug it into that quadratic formula. So I have negative of 1 plus or minus the square root. I have 1 squared minus 4 times 2 times negative 5 all over 2 times 2. Now we just start simplifying that down. So I end up with x equals negative 1 plus or minus. Now we do the discriminant, all that part underneath there, the radicand. So 1 squared is 1, 4 times 2 is 8 times 5. Negative 5 is a negative 40 plus, or so it's going to be 1 plus 40, which would give me square root of 41 all over 4. So if it asks for simplified radical, that would be your answer. If it wants it as a decimal, what you're going to do, remember, you're going to go the negative 1 plus square root of 41. And then you're going to go take that answer and divide it by 4. And you should end up with your first answer would be 1.35. And then you're going to come back, change that subtraction to a negative. So 41 square root, make it negative though. And then we're going to minus 1 from that. And then we're going to take that divided by 4, and we end up with negative 1.85. Okay, so there are our two solutions to that. All right, we're nearing the end here. So we're going to look at this last part, solving radical equations. So just like up above, we isolate the radical, but this time instead of square root, we take the square of both sides, and then we can continue to solve the equation. Make sure you check your answers, make sure you're not doing anything that causes that to give you an extraneous solution. So here I'm isolated, so my next step is I'm going to square both sides. So that's going to get me x equals 81. If I plug that back in, square root of 81 is 9, so that one works great. On this second one here, the first thing I need to do is get rid of this 4. So I'm going to add the 4, and the reason for that is that's my radical there. So I end up with the square root of x plus 2, and that equals 6. Now I'm isolated, so I square both sides. So I get x plus 2 is equal to 36. I minus the 2, and I end up with x equals 34. Then I take that, add it 2 to it, that's 36. Square root of 6 minus 4, that's 2. Worked out perfect. Okay, if we look at this one, this third one down here, you'll notice I have two radicals, but they are both isolated. So I'm going to take and I'm going to square both of those. So that would cancel out the square root, and I'm left with x plus 3, and that equals 3x minus 5 because that cancels out as well. Now at this point, I'm going to minus x from both sides. That would get me 3 is equal to 2x minus 5. I'm going to add my 5 to both sides. That gets me 8 equals 2x. Divide that by my 2, and I get x equals 4. Now, just double check that. So if I plug the 4 in, 4 plus 3, that's 7. So that side would be a square root of 7. 3 times 4, that's 12. 12 minus 5 is 7. That's also the square root of 7. So both of those work perfectly. On this last one, you will notice my radical is isolated, so I am ready to square both sides. So I do that, and that's going to cancel the radical, so I would be left with 5x minus 6 equals x squared. Now, since you have an x squared, that kicks it into being a quadratic. So your very next step is you are going to minus 5x from both sides, and you are going to add 6 to both sides, and you're going to set this equal to 0. So x squared minus 5x plus 6. Now, at this point, you would factor this. So that's going to give me x, and I look, the signs would be the same. I look back, they're both going to be negative. Factors of 6 that add to 5, and that would be a 3 and a 2. So now I go x minus 3 equals 0, so either x equals 3, or I'm going to go x minus 2 equals 0, so x would equal 2. And I look, if I plug 3 in, 5 times 3 is 15, minus 6, that's 9, and square root of 9 is 3, so that one works. 5 times 2 is 10, 10 minus 6 is 4, square root of 4 is 2, and that one would work as well. Okay, so that is how we solve those radical equations. Last questions that we're dealing with here is just a quick review of Pythagorean theorem. So remember, Pythagorean theorem is a squared plus b squared equals c squared. In other words, leg squared plus leg squared equals hypotenuse squared. So now when you look at this, the first thing you should do is draw a picture. So it says, I have this garden. The garden is 14 feet wide. So I'm going to call that wide there. And 20 foot across the diagonal. So this is 20 foot. And we want to know how long is it. So if you look, I have a leg here, I have a leg here, and then I have the 20 foot would be the hypotenuse. So if I set up my equation, it's going to be x squared plus 14 squared equals 20 squared. Now we square those, so 14 squared is 196, 20 squared is 400. I'm going to take that and I'm going to minus 196 from both sides. So that would leave me x squared is equal to, 204. So if I look at that, I take the square root of that. And now I'm simply going to ask myself, is there any perfect square factors that go into 204? And the answer would be yes. It is 5 times 51. So the square root of 4 comes out. So that's going to leave me x is equal to 2 square root of 51 feet. That is my exact answer if they want it as a radical. If they want it as a decimal, you would literally take this and you would say, what is the square root of 51 times 2? And that would get us 14.3 feet, rounded to the nearest tenth. And guys, like I said, this is not an all-encompassing lesson of everything. It is just kind of an overview of some of the topics to hopefully get your brain back onto them and get you going again for the semester final. All right, happy studying and good luck in a couple days when we take the final.